Okay, so let us solve this problem, analysis of frames for example number 2. So determine the components of the reaction at the fixed support D, okay, and the pins at A and C. Of this three-member frame, neglect the thickness of the members. Draw the shear moment and axial diagram as well. Okay, so let us identify first the reactions of this frame. Okay, for part A, support A, so since this is a pin or hinge support, so we expect to have a vertical reaction and a horizontal reaction. So okay, so let me call this as RA horizontal, and this is RA vertical. Okay, while for at joint D, this is fixed support, so we'll having a vertical reaction. So let me call it is RD vertical, and there will be a horizontal reaction here, so let me call it as RD horizontal. And there is a moment, okay, since this is a fixed support, so we expect to have it a moment. Okay, so let us call it as moment at D. Okay, so for the direction of the moment, we could assume either clockwise or counterclockwise. So let me assume that the moment here is counterclockwise. Okay, so let us solve uh, for the reactions. Okay, so what equation of equilibrium can we have? Okay, so if we take moments at A, so we'll be having three reactions unknown. If we take moment at D, we will have also three reactions unknown. So what we're going to do is to isolate members. Since the joints B and C are also pinned, so we could take advantage of that. So let's say let us isolate members, say AB. Okay, so the vertical member AB. So if you will take a look of that, okay, so let's say here's the vertical member AB. Okay, so we have the RA vertical, and let's say to the right is RA horizontal. Okay, so at that joint B, since this is hinge, so there will be only horizontal and vertical reaction. Now considering the load, so as you can see from the load, we have a uniform load which is distributed in the entire length. Okay, so that's 0.5 kips per foot. Okay, so with that, since the uniform load is to the right, so this most likely it would be to the left. Let's say RB H, and this would be downward RB vertical, and okay, so this uniform load is directed to the right, and the distance, okay, or the length is 4 meters here and 2 meters here, so total of 6 feet rather, 6 feet. Okay, so if we take moment, so applying a statics here, let's say we sum up moment, say B equal to 0. So let's say clockwise is positive, so what are the moments at point B? So of course these two reactions will disappear, so we will just have these two reactions. RAV will be passing through point B also, so mawawala rin siya, so yung RAH na lang, so that would be positive RAH kasi it causes a clockwise direction about B. The moment arm of RAH is 6 feet, then the uniform load is minus, which is 0.5 times 6, the resultant, and the moment arm is 3. Wala na, so everything is equal to 0. So if I compute for that, 0.6 times 6 times 3 divided by 6. Okay, so that would be 1.5. So from here I could say that RAH is 1.5. Okay, so that is keeps, and that is positive, so that means the direction assumed is upward, correct. Okay, so of course if we sum forces horizontal equal to 0, vertical, if we sum up forces vertical equal to 0, let's say pataas or positive, of course the RAB minus the RBV would be equal to 0. So from there I could say that wala pa na. So we could say here that RAV would just be equal to RBV. But since we have already solved for RAH, we could sum forces horizontal equal to 0. Let's say to the right are positive. So what are the forces? Okay, so negative RAH, which is 1.5, tapos negative RBH, tapos plus yung uniform load, which is 0.5 times 6 should be equal to 0. So from here we could solve for the RBH. So by symmetry, actually it would just be the same with RAH. Okay, so that would be 1.5 minus 0.5 of 6, so that would be 1.5 also. Okay, so this is 1.5 keeps. The direction of RAH should be the same with the unknown, which is to the left, and the reaction of RBH would be also to the left. Okay, so from this segment AB, we cannot solve for the reaction A vertical as well as yung RB vertical. Okay, so next is we're going to isolate. Member BC naman. Okay, members BC. Okay, for member BC, so we have this member. Okay, tapos meron tayong load. Ang load natin dyan, uniform load ulit, same lang. So ito yung uniform load, and the magnitude of the uniform load is 2. So 2 kips per foot. Okay, so since they are pinned din, diba? So pinned silang dalawa. So itong point B, from action-reaction coming from this point, so if we assume this to be the direction, so action-reaction, it would be opposite. So kung downward yun, it would be upward. RBV, tapos yung to the left, ito magiging to the right, which is the RBH. Okay? Tapos sa kabilang dulo naman, it could be to the left, yun yung RCH, at saka pataas yung RCV. Okay, then the length of the member BC is 8 feet. So 8 feet. Ayan, so from there we could apply statics pa rin. Alam naman natin antimano yung RBH, no? So yung RBH na solve na natin kanina, which is equal to 1.5. So this is already 1.5. This is 1.5. Okay, so kapag ka nag-summation tayo ng forces horizontal equal to 0, so that would be RBH positive, which is 1.5, tapos minus yung RCH, would just be equal to 0. So therefore we could say that RCH is also equal to 1.5. Okay, then kapag ka nag-summation moment naman tayo sa C equal to 0, let's say clockwise positive. Okay, so moment tayo sa C dito, So we have RBV. We have RBV. The moment arm is 8 and that is positive kasi clockwise. Okay, tapos yung uniform load. Yung uniform load naman is counterclockwise, so minus 2 kip per foot times 8 resultant times the moment arm is 4. Okay, so wala na, everything is equal to 0. So from here I could solve for RAV. 2 times 8 times 4 divided by 8, so that would be equal to 8. So positive yung 8, so that means RAV is upward. Okay, then of course pagka nag-summation forces vertical naman tayo equal to 0, we'll have RBV. RBV naman is RBV, so this is RBV. So we'll have RBV vertical plus RCV minus the uniform load, which is 2 times 8 equal to 0. So actually we could solve there yung RCV naman. Okay, RCV equals, so this is RCV, so that is equal to, so 8 times 2 plus minus RBV, which is 8. So actually it's also 8. Okay, so 8 kips and that is upward. Okay, so what else? RBV. So yung RBV din na to would just be the same with this RBV over here. Okay, so di bali ano na ulit yan, lagyan natin dito yung sagot. So yung RAH is 1.5. okay, tapos yung RBH ito is also 1.5. then RCH is 1.5 also. Tapos yung RBV ito, that is 8. RBV rin to, 18 to. Then if we sum up forces vertical, sabi natin they are equal. Diba yung RAV tsaka RBV equal yan, so this would be also 8. Yan. Okay, now how about RCV? What do you think? RCV, nasolve na natin yan, this is also 8. Okay, so what's next? Okay, next is to isolate CD. Isolate CD. Okay, for isolate CD, so let's write it here. So isolate CD. Okay, for isolate CD, so this is C and this is D. Okay, so this is 4 feet. Tapos wala naman load, no? So 4 feet, so walang load. So di bali meron lang dito RDV. Sorry, this is C, this is D. So we have RD vertical, tapos yung RDH ito kaliwa, RDH. Okay, tapos yung moment na inassume natin, which is moment at D. Tapos sa kabila naman meron tayong based from BC, isolate member BC. Yung RCH natin kaliwa dito, diba? Kaliwa dito. So pagdating dito magiging kanan. RCH, and nasolve na natin yan as 1.5. Tapos yung sa taas, yung RCV, nakuha natin 8 feet, 8 kips na pataas, so magiging pababa naman to. Okay, so na 8. Okay, so if we apply statics here, summation of say forces vertical equal to 0. So diba yung RCV or RDV minus RCV, is silang dalawa lang equal to 0. So therefore, RDV is equal to RCV, which is equal to 8 kips. Okay, which is pataas. Okay, now pagka nag-summation forces horizontal ka naman equal to 0, yung RCB, yung RCH kanan minus RDH. Okay, so equal to 0. So from there, I could solve that RDH is just equal to RCH, and that is equal to 1.5 kips. Okay, so yung RDH natin is kaliwa. Then lastly, so if I sum up moments, say moment at D. So pag nag-moment ako sa D, let's say clockwise is positive, so I'll have negative MD. So kasi inassume ko siyang counterclockwise. So yung reaction sa D will disappear parehas. Ganun din yung vertical dito, yung RCV. So magkakaroon lang ako ng RCH. RCH would be positive clockwise. RCH times the moment arm of 4, okay, equal to 0. So from there, I could solve for MD. And RCH is actually 1.5. So that would be 1.5 times 4. 1.5 times 4. So that is 6. Positive. So ibig sabihin, tama yung direction natin. So this would be keep foot. Okay, so and that is counterclockwise. Okay, so yan, we have analyzed the 3 segments of this frame. So we're now ready to draw the diagrams. Okay, so let's try drawing the diagrams. Okay. Okay, so okay. So how do we solve for how do we draw the diagrams? Okay, so let's start with AB. Okay. Okay, for AB, so 0.5, actually, ito yun, no? Okay. So let's have here the diagrams. Okay, so let's say member AB. Member AB is 6 feet. Okay. So member AB. Okay, so ihihiga ko siya muna, no? Okay, ito si member AB. Okay, ito si A. Ito si B. Tapos may loads siya, no? So yung loads niya transverse. So uniform load yung 0.5. Okay? So 0.5 kip per foot. Okay, tapos yung kanya is 6 feet. Okay, so tapos nalaman natin yung Okay, so yung so we have 1.5 yung mga reaction horizontal tsaka 8 compression. 1.5 tsaka 8. So di bali ito yun 1.5, tapos may 1.5, ito yung 8. Compression yung 8. Okay, so let us draw the diagram. So simple lang naman. Okay, so let's start with the shear diagram. Tapos later on we'll have the moment diagram, and yung huling part it would be the axial diagram. Okay, so let's start with the shear diagram. So for the shear diagram we have 1.5 going up. Okay, so 1.5, then you have a uniform load of 0.5. So 1.5 minus 0.5 times 6, so we have negative 1.5. So negative 1.5, so it would be somewhere here. So 0 degree yung uniform load, it would be first degree. And so since parehas silang 1.5, ito negative, so this point of intersection would be kalahati ng 6. It would be at 3 feet. 3 feet. Tapos may 1.5 kang pataas, so you go up. Negative 1.5 plus 1.5, so it closes the diagram. So it involves this area of the triangle over here, tapos may area of the triangle din dito. Ayan. Okay, so tapos let us consider naman yung ano moment diagram. So basically the moment diagram is based from the area of the shear diagram. So di bali first degree maging second degree. Okay, and the area of the triangle would be 1/2 base times height. Okay, so that would give us 2.25. So the maximum moment is 2.25. First degree it would be second degree, and the shear is decreasing, so decreasing slope. So the moment diagram is somewhere like something like this. Then the same area ng triangle, so bababa ka lang and it will make it 0. So the moments at the ends are 0 since the ends are pinned. Okay, now how about for the axial diagram? Okay, for the axial diagram, so we just have to take into consideration that pagka tension siya positive, tas pagka compression it would be negative. So as you can see, yung 8 natin dito, yung 8 kips natin dyan is compression. So isabihin yung diagram natin is negative. So bababa tayo ng negative 8, and the axial naman is constant all throughout the member. So constant lang yung compression, then negative 8. Okay, so this is the axial diagram. Okay, so yan. So yan yung sa member AB. Okay, next. How about for member BC? How about for member BC? Okay, for member BC naman, okay, so ito si B, ito si C. Okay, so diba ito yung horizontal member natin na 8 feet, tapos may 2 na uniform load. So may uniform load siya rito na 2. Okay, so 2 kip per foot, tapos 8 feet yung length niya. Okay, for member BC, these are hinge din. Okay, so ito siya. So di bali meron tayong 1.5 to the right. Okay, so we have 1.5 to the right, tapos 1.5 to the left. Okay, tapos may RVB tayo na 8 pataas. Tapos dito rin meron tayong RC vertical na 8 din. Okay? So, drawing the shear and moment diagram, so simple lang naman, no? So, parang simple beam lang siya. So, drawing the shear and moment diagram. Okay, so let's start with the shear. Then, let's have the moment later on. And at the same time, yung compression. Yung axial. Okay, so for the shear diagram, so alam naman natin, no? For the shear diagram, it would be 8 pataas. Then, 8 minus 2 times 8. So, that is 16. So, negative 8. Then, 8 ulit pataas. So, that's the shear diagram. So, it consists of 2 triangles. And of course, this point of intersection would be kalahati ng 8. So, 4. Ito rin ay 4. Okay? So, next is for the moment diagram. So, the moment diagram is similar to this one. The moment here is 0. Tapos, maximum moment at the point of 0 shear. Diba? So, increasing, decreasing shear. So, decreasing slope. And the magnitude of the maximum moment would be the area of the triangle. 1/2 base times height. Okay, so we have 16. So, 16 yung maximum moment. Then, you go down of second degree din siya. Okay, so these are second degree. 4 times negative 8, then 1/2 of 8. So, 16, negative 16 din. Then, for the axial diagram naman, so since this is compression 1.5, so again, pababa. So, negative compression 1.5. Okay, so constant naman yung axial compression. So, this would be the axial diagram. Lahat compression. Okay, then last would be for member CD. Okay, member CD. Okay, for member CD naman, so the length of which is 4 feet. Okay, so let's have it here. Okay, so yung member niya, maikli lang, 4 feet. So, ano yung mga forces? So, so dito meron siyang RDV. No? So, ito yung RDV. Ito yun, no? So, ito siya. Okay, so we have RDV. RDV is how much? RDV is 8. So, 8. Tapos, meron kang RDC. RDH, rather. So, may RDH tayo rito. Ang RDH natin, ilan ba? 1.5. So, 1.5. Tapos, may moment tayo na counterclockwise, which is 6. Tapos sa kabilang dulo naman, sa point D, meron tayong pababa. So, pababa na 1.5. Tapos may kaliwa tayo na 8. Okay, so walang moment, tas wala tayong load. Okay, so if we were going to draw the shear moment diagram and axial diagram of this, so ganito lang siya. Okay, so starting with the shear diagram. Okay, for the shear diagram, you go up with 1.5. So, okay tayong 1.5. Tapos, walang load. So, constant lang yung shear, 1.5. Tapos, bababa tayo na 1.5 din doon. So, di ba yan yung shear diagram, rectangle. Okay? Tapos, pagdating naman sa moment diagram, so, moment diagram, ito, let's say, okay, for the moment diagram naman, so we have 6, diba? May 6 pababa, negative moments. So, we go down by 6, so negative 6. Tapos, meron tayong area ng rectangle sa shear diagram, which is 1.5 times 4. So, that is positive 6. So, negative 6 plus 6 it would be 0 here. And this is 0 degree. So pagdating dito, first degree, straight line. Okay, so 1 degree. Then for the actual diagram naman, no, for the actual diagram, as you can see, ano ba? Compression din na 8, 'di ba? Compression na 8. So pagka compression na 8, so pababa siya, compression eh. So negative 8, compression constant, plus negative 8. So ito ngayon yung actual diagram. Okay, so basically yan ang magiging kompletong shear moment and actual diagram ng frame na given, consisting of 3 members, AB, BC, and CD. Okay, so simple lang. So I hope you have learned out of this simple problem. Okay, so thank you.